Hello everyone, I hope you are doing well. So today I will explain my homework that was assigned to me in ARM32 assembly. Okay, so before coding part of our video, let's call it like this, I wanna show you the instructions that we have to follow. So basically, what do we have to do? We have to see how looping and branching are implemented in ARM32 assembly. And usually, big condition branch is used for it, but unfortunately now we are not allowed to do this. That's why we will find different ways of implementing it. Yeah, so basically let's see the algorithm that we have to implement. So the purpose of our code is to compute the sum of all integers from m to n, where m is the initial point, like starting integer, and n is the stopping one. Okay, and the sum is going to look somehow like this. Let me show you. M plus 1, m plus 2, and continue. Okay, so let's start coding, and before that I want to share something minor about looping. So looping basically is when the program repeats something over and over again. It's like in daily life as well. For example, people say hi 5 times. Non-stop saying hi 5 times is also considered as looping. So basically repeating the action that is repeated. Yes. Okay, so let's start coding. For the coding part, we will use the CPU later, which provides us with the place to code, basically. Okay, so the first step is to initialize our starting and stopping values. So let's start our value, and basically this is the first register, and so we initialized R0 and it's our starting integer to 1. So this basically shows the value that was initial, like basically the value that was given. Then we also have the ending value, because from here we can understand that m is our starting integer and stopping is n. Okay, so let's initialize R1, our stopping integer, to, for example, 3. Okay, then in our program, in our statement, it's written that the sum has to be in R2. So we also create R2. We initialize R2, our sum, to 0. You may ask me why the sum is 0. By the way, I'm so sorry that I'm not visible throughout the video, because when I'm code, this thing fades away. That's why I will try. Oh my god, what's that? Sorry. 1 second. Yes, that's why I will try to show my face as much as I can when I explain something. So basically we initialized R2 and the sum is 0. Why is it 0? Because because the sum starts from 0, basically, yes. So if this line is omitted in our code, then the sum would start with an unknown value, leading to incorrect results. That's why it's very important to initialize it. So we are done with initializing the registers, and now we will write a very interesting line of code, which is loading the offset. I will explain what it means in a couple of minutes after writing the code. Okay, this line basically represents what? You may ask me why it's equal to 4, why is it like this? So basically, it's not that hard. This line basically loads the value 4. We wrote it as LDR, which is the size of a word in ARM32, into R3. Basically, this value will be used to calculate the number of bytes per word. This line ensures correct word handling, and omitting this, kind of ignoring this line, it might cause some issues with memory addresses or branching calculations. That's why it's very essential for us. That's why it's very important to initialize it here. Okay, so let's go to the next line of code, which is setting R5 to address of loop. Don't worry, I will explain everything. So address is written ADR, and R5 we addressed R5 and loop. Okay, so basically what does it show? This sets R5 to the address of the label loop. This address will be used to branch back to the loop when it's really needed. And without this line, the program wouldn't know where to jump back for the further iterations. So that's why it's very essential for the program to understand like when and where it can jump for like future iterations, let's call it like this. And we will have one more very interesting line for addressing with the same command, ADR R4 to finished. Yes, why finished, you may ask me. Basically, this line shows R4, sets R4 to the address of the label finished. So this is our label and it's called finished. Yeah, so this is used when the program needs to exit, and without this line, if this line is kind of disregarded, ignored, if we don't write this line, then the program wouldn't have a proper exit condition. So the behavior is going to be crazy here. Like after the loop finishes, like it wouldn't know how to properly act. That's why it's really important to write finished label to basically show that the program stops. Okay, so let's start our loop because yes, 1 second, let me check if everything is right. It's initialized. Okay, it seems that everything is correct, so let's go to our loop. So in loop we do the following. Firstly, like as we have two values, let's call them like this, like starting value, the stopping value, we have to compare them, and comparison is written as CMP, and we basically write the R0 and R1 because, again, as I've mentioned, this is the starting and stopping point. Yes, why is it needed? So basically this compares R0, our current integer, with R1 with the stopping integer. The result of this comparison will basically determine whether the program continues iterating or finishes. And without this comparison, the loop would not know when to stop, and again, it's very bad for the program. That's why we have to show when, that's what we have to compare, because the loop would not know when to stop without that. Okay, then the next line of the code is idle. I will explain everything after writing down this line. Sorry, R2 and R0. Okay, so what does it mean? So this line basically says that if the condition, so we have a condition, let's write down it like as a comment, R0 is less than or equal to R1, then it's true, and this line adds the value of R0 to R2. So this is our sum, and the sum is written like this. Yes, without this line, no summation would occur. That's why it's very important, and the sum has to look like this. That's why it's really, really important. Then the next line is idle R0, R0, and 1. So basically, we know for now that this is the summation, like incrementing, like this thing. So basically, again, so if the comparison R0 less than or equal to R1 is true, this increments R0 by 1. Without this, R0 would never increment, causing an infinite loop if the stopping condition is not met. So again, like if we didn't have this, line, then we would have an infinite loop, which is not recommended for us. Okay, so what do we do next? The next line is very interesting. Here are where the things are getting serious, more serious. Okay, so this line, again, like add, we already know what it means. So it calculates the address to jump to after the loop ends. The address finished, because see, like R4 finished, yes. Storing it at R4. This line is very, very important for proper branching, and without it, the program wouldn't have the correct address to jump. Okay, then the next line is PC R5. Okay, why this line is important? Let me briefly say what it means. So it basically means that if the comparison was less or equal, like as we already written in the comment section before, the program jumps back to the loop label. Omitting this line, kind of ignoring this line, would prevent the program from correctly looping and summing the integers. That's why it's very, very important to add this line. Okay, and the final line in our loop is this one. Shortly, what it means, it basically means that if the comparison was greater, branch has to be finished, because R4 is finished. Okay, so basically, let's write it like this. If R0 is more than R1, then the program jumps to finished label, because it's not correct. Yes, without this line, the program would continue looping even after the condition is met. So it's very important for us to kind of stop the loop from repeating itself over and over again even after the condition is met. Okay, and the last line of code is, okay, so we write finished and we exit the program. Again, so basically let me explain the last line as well. So it basically shows that we call the system call to exit the program. So without this line, the program would continue running even after the finishing. That's why it's very important to finish. Okay, so again, let me quickly recap why all lines here are important and what would happen if we removed them. So our initialization of registers until here, these first 3 lines, would cause incorrect starting values for the loop and sum. But starting values are very important here. That's why we cannot miss them. Missing the comparison, which is here, or increment, this two, yes, this one increment, yes. So it would prevent the loop from functioning correctly. And omitting branching instructions, for example here, yes, this, yes, it would lead to infinite loop or incorrect program flow. And so we are basically done with, yes, so we are basically done with coding, and let's compile and see how it works. So for compile, we have the button here, let's press on it. Okay, and let's see if the program works. Okay. Yes. So as you can see, the program works, and we have done an amazing job. Yes, so yes. Okay. So thank you very much for watching the video. I hope it was very helpful and hopefully you learned something. It was very interesting for me to explain everything. Yes, so thank you very much.